Hey there, welcome back. I'm Blake Green. I'm a cloud architect and AWS community builder. Today, we're going to be going through the AWS Cloud Development Kit Primer. This is a training and certification course that's provided through AWS. It's totally free. You can, anyone could sign up for it and go through it. And I thought it would be kind of fun to sort of live stream my way through this. I've done a lot of CDK, streams in the past. So it's kind of in line with, what I'm interested in and what I'm working on. So, yeah, I thought it'd be kind of fun to go through sort of the fundamentals of the CDK and see what this course has to provide. I'll drop a link in the comments below, but if you just probably Google AWS Cloud Development Kit, it'll drop you to this page, and then there's a sign in, sorry. And then, obviously you can go ahead and create an account, or if you have an existing one. I already have an APN partner account, so I'm just going to go ahead and sign in with this, and yeah, we'll get started. So yeah, I've kind of already clicked into the to the course to just kind of get a feel for it and see what it's about, but it'll eventually pop up with the course materials. But really quickly, the course description here says this course is an introductory course to AWS CDK. This course teaches developers how to model, provision, modify, and delete cloud applications resources using familiar programming languages. Design reusable components that meet the organization's security, compliance, and governance requirements, and use objects, loops, and conditions to accelerate and add logic to your development and deployment process. So that's, at a high level, what we're going to go through. It also goes into, more of the course outline. So you can see there's about 7 modules here that we're going to get through. And yeah, so let's dive in. So yeah, when you first jump into the course, it'll drop you into, obviously, I think it provides these like directions to kind of give you a feel for how to maneuver through the course material. But essentially, it's pretty easy to just kind of click your way through it. But it starts off with, what is the AWS CDK? It's application development in the cloud is the demanding process. Developers must have a strong grasp of the application deployment process to ensure their application correctly provisions on the required infrastructure. I think eventually we'll get to the point of writing some code, but I think this first module is a lot of theory to sort of learn more about what the CDK is and what it provides. Okay, so using AWS Cloudformation, AWS CDK then provisions the cloud infrastructure resources with the help of command line tools. So we know in previous streams that under the hood it's using Cloudformation. What does AWS CDK do? Compiling your source code into an assembly language is a common code development process. Think of AWS CDK as a compiler that compiles your source code into AWS Cloudformation template. AWS Cloudformation templates are used to create the cloud infrastructure. The AWS CDK then uses the templates to create the cloud infrastructure. CDK also enables developers to use common code development practices by offering tools to check for potential problems and identify code differences and bootstrapping resources for deployment. So I really like this diagram here. I think it definitely shows like the different levels of CDK like application. Like at a high level, you're obviously using this CDK framework, and then within that, when you do the CDK init command, you're creating an application, and then within that application, you can have obviously one or more stacks, right? And within each of those stacks are constructs, and constructs can be like obviously like a one-to-one mapping, or it could be one or many different resources or services inside of a construct. So like you could go down to layer one and it's like just a normal like one-to-one mapping of a CloudFormation resource, or it could be like the uh, application or Fargate application load balance service or whatever, where it has like a load balancer, a Fargate service, task definition, all that stuff. It's all wrapped up into one construct. And I think that's kind of what it's showing here, right? You got the ALB with multiple containers across an AZ and a VPC. That could all be one individual construct, which is definitely that's like the power of a CDK. So this example diagram demonstrates the ability of the AWS CDK to deploy cloud infrastructure into the AWS cloud. A developer interacts with the AWS CDK and its three main components: app, stack, and construct, to synthesize AWS CloudFormation templates. Then deploy AWS resources for their organization's users. So here it breaks down the three main components of the framework of the CDK. And you can see here, like, kind of similar to this diagram up here, it breaks down into constructs and kind of. So a construct is the basic building blocks of the AWS CDK. A construct represents a cloud component and encapsulates everything that the AWS CloudFormation needs to create the component. And like I said before, right? So it's a construct can represent a single cloud resource, such as a Lambda function, or it can represent a higher level component consisting of multiple CDK resources. Stacks are a unit of deployment in the CDK. All AWS resources defined within the scope of a stack, directly or indirectly, are provisioned as a single unit. Yeah. So that's more of like a one-to-one mapping of like what you see in the CloudFormation console, right? It's like this is a stack that includes all of these constructs. And then finally, you have the app. Your CDK application is an app and is represented by this AWS CDK app class to provision infrastructure resources. All constructs that represent AWS resources must be defined directly or indirectly within the scope of a stack construct. So the importance of AWS CDK for your organization. Let's see. Yeah, so obviously the first one is reuse your infrastructure as a library, and that's I think that's so big. Like it's like during customer engagements, you obviously don't want to reinvent the wheel. It's uh, how can I be more efficient and sort of grab these reusable libraries off the shelf in the event that I need to spin up a VPC that I know is secure and built with best practices, rather than trying to like recreate a several hundred lines of Cloudformation to accomplish the same exact thing. It doesn't really make sense. So it's definitely one of the benefits of using the CDK. Um, so it goes into additional advantages of using the AWS CDK. Achieve faster deployment by expressive programming languages for defining infrastructure. Incorporating features such as objects, loops, and conditions. Yeah, like using an IDE for code completion. Let's see. Object-oriented techniques to create models of your system. Organizing your project into logical modules. Testing your infrastructure code with like PyTest or Jest, right? How AWS CDK interacts with supported programming languages. Now, this is the real magic here of the CDK, in my opinion. So AWS builds the business logic of AWS construct library packages in TypeScript and uses the AWS JSII to provide mappings to each supported programming language. So yeah, I mean, maybe I'll go into more details here. Oh, yeah. So I mean, here's a link to the GitHub repo, but you could think of like the this JSII project is like you write your construct in TypeScript, and then you're able to sort of like deploy it to compile or transform. I don't even know. It's pure magic in my opinion. And all of a sudden you get the same CDK um, library or module in Python or Java and all the other supported languages that JSI can just like push out into those other languages. It's crazy. All right, so AWS CDK demonstration. In this demonstration, you will learn how to create an AWS ECS cluster from an image on ECR. You'll use AWS Fargate with internet-facing application load balancer to create the cluster. Okay, so it goes through like a lot of the prerequisites for having all this. If you prefer all that stuff. Let's see here. Okay, so maybe it just so it has this little video here, I guess, that walks you through it. Let's see if we can. I wonder if this is the. Let's take a look at this guy. Okay, so it looks like this just includes some, here, I'll bring it over. Sorry, forgot to bring it over to the other side here. Let's see. All right, so I'll open this up in VS Code. Oops. And so basically, if you were to download this this text file, it gives you all of the instructions that you need to follow this project here. So yeah, all right, let's give it a shot. Real quick shout out to this other tool that I found. It's called Leap. Yeah. Here it is. So if you you use the AWS CLI very often, this tool is amazing. You can authenticate with your identity provider, like for your single sign-on, and then once you logged into your organization, it will list all of the accounts that you have access to with the roles that are assigned to your account, and basically allows you to grab an STS token. Here's a good look at, because I'm not going to be able to show it on my on the screen because I don't want to share all my account information, but basically it's literally as easy as clicking on a particular account with a role, and it will automatically configure your AWS CLI for you to be able to interact with that account. It's still very early days. I've noticed it's a little buggy, but for the most part, it's super simple to use, and you can turn it on and then turn it off, and it removes your temporary credentials right away. And it's really nice to be able to switch between AWS accounts. So highly recommend using this. And I think it's just going to continue to get better. So let me go ahead and log in here. Oh, and then as soon as I say that, right? Okay, so I'm already logged in with my account here. So let me open up a new VS Code. All right, so if we come over here and we have this, empty directory. I just called it CDK Primer. And then if I open up the other, let's see, where did it go? Here. Let me just put that over here. And we'll just go full screen. Okay. So let's see here. So we'll create the main project folder and open a terminal in VS Code. Check. So we're in CDK Primer. Navigate to the newly created folder. Yep, did that. Okay, so now we can initialize our application, our CDK application. So language, TypeScript, and this should, build out our initial CDK application. I should get better at the timing, as far as like every time like an npm install runs, I should know like that's when I should grab a drink of coffee, because it takes forever to npm install the internet. But anyways, so now we just need to bring in our dependencies, right? So we're going to use the AWS EC2 module. And so really quick on, I think, version 2 of the CDK, this will all go away where you have to install each individual module. So like I think it'll just be AWS CDK like cloud components or something like that, which will be really nice, because then you don't have to like npm install all of these different modules. That's just, it's too hard to keep up with, especially in like Python projects, because you have to include it in the setup.py file. Okay, so we'll npm install those guys, and then in the npm, or sorry, in the in our project here, we can open up the CDK Primer stack.ts in the lib directory. And I'll bring this one over on this side. So this is like our, the bare bones CDK application. It's our entry point into creating the CDK resources, right? And let's see here. And now we need to add our imports to be able to use them right inside of our CDK application, now that we've installed these the modules. And so I'll just copy and paste that into here. I hope that's big enough, but we'll go full screen there. All right, and then under the comment that indicates where the stack resources are included, add these lines so that we can create this guy. So let's just try to let's write this out a little bit so that we get the feel for writing a CDK application. So you create a VPC, so new EC2 dot VPC, and this my VPC, and then we give it some properties here, and we want to say max AZs are 2, right? So and like, again, like I think this really shows the power of using like an IDE like VS Code. Is now like oh man, what's the auto? I think it's, nope, that's not it. I don't want an emoji. Is it that? No. There you go. So control space. Control space, right? So it shows you all of the available properties of this VPC um, resource, right? So now I can like specify the CIDR, if flow logs are enabled, and I can scroll down to these, and it tells you sort of like flow logs to add to this VPC. And obviously these are all question marks because they're not required. They're optional properties, but just gives you an idea like of how easy it is to sort of develop within the IDE, and be able to quickly see what resources or properties are available. So pretty cool stuff. So we'll keep going. Cluster equals new ECS dot cluster. This my cluster. And then we pass in the VPC. I think we could just do that, and it should know that we're using this VPC. So okay, and then finally, we need to create a new ECS pattern. We're going to use the ECS patterns module, which includes like a ton. This is like one of those. I think you'd call it like a layer 2 construct. And you can see here, like I was talking about earlier, is that we can include like these application load balanced EC2 service, right? And that includes obviously several AWS resources that are like sort of bundled into this construct that has like all these best practices built into it. So now you're not like worried about IAM permissions, or a lot of that the nuance that goes into it, because that these constructs are built with all of that security and stuff in mind, right? So yeah, so we'll select the application load balanced Fargate service, and we give it this for the scope, and then we give it a name. So my Fargate, and then we'll say cluster, and then task image options. This thing here down here. So okay, and then we need an image, image, and now we're again using the ECS module to get the container image from registry. So here it's saying like we have a couple options, like from asset could be a Docker image locally on like within our project, or our local file system. Docker image asset, I'm not sure what that is actually. Use an existing Docker image asset for this container image. We could also use an image from an ECR repository, or this from image like function is, I'm sorry, a method, same thing, I guess. It defaults to Docker Hub, right? So we can pull an image from Docker Hub, and we can say Amazon /Amazon ECS what's ECS sample. Okay. So I think that's it for. Oh no, missed. Oh, okay. Sorry. So task image is an object, and then public load balancer, and that's a Boolean, and we'll say true. All right. Cool. So if we save that, now, I mean, that's it. Like that is our, this is our CDK application. We have a stack within our application, and then we're using these constructs within the stack. So now we can go ahead and run like from the terminal. So I'll clear from the terminal. You can run CDK synth. And what this will do is like synthesize, this code from our TypeScript and sort of like compile it into Cloudformation. So it sort of transforms it, and so that when we run the CDK deploy under the hood, it's just all Cloudformation templates, right? And so it outputs, sort of like what it's going to do. And you can see, I mean, it's just a ton of YAML that we would have written otherwise, right? With CloudFormation, but instead, it's just 24 lines, give or take, of TypeScript, and we're getting all these like best practices built into the CDK application. So pretty powerful stuff there. Let's see, what else does it say? Yeah, so it goes through like the deployment process. I mean, it's pretty straightforward. Well, you know what? Let's do it. Let's deploy. Let's send it. CDK deploy. Go for it. Hopefully this doesn't cost me a bunch of money, but whatever. It's just money, right? Burn it to the ground. I made a bunch of money on GameStop anyways, so I can afford to run a Fargate service for a couple of minutes. I'm just kidding. I didn't catch that train. So, oh man, unable to resolve AWS account to use. What? That's a weird one. Okay, let me try this again. Okay. See, so like I went out on a limb here and gave a shout out to Leap, and now their freaking app isn't working. Classic. So this is Leap, and it should. Let's see here. I don't want you guys to see my credentials, so no offense, but I don't want everybody deploying application load balance Fargate service in my account. So, all right, let's try that again. Which is kind of weird. I don't know why the CDK synth worked, but the deploy didn't. I thought if you haven't authenticated, then it wouldn't run the synth either, but I don't know. All right, so I restarted my Leap app there, and there it goes. So it kind of like before you deploy, it's like, hey man, are you sure you know like the IAM potential here for disaster? Yeah, I totally get it. I'm ready to go. So at the end of this, and another thing here is like you'll notice that we didn't even like output the URL of our load balancer, right? Like, or the DNS name for our load balancer, but that's already built into this ECS patterns construct, So it when this runs, it'll just be like, hey, click on this URL, and then we should see our CDK application or whatever this Amazon ECS sample is from Docker Hub. I don't think I've ever actually used that before, but anyways, okay. So that is deploying. When the deployment is complete, in the output section, we'll be able to see that. Then we can also log into the console and see, the Cloudformation stack, and see, all the resources that it deployed. Then it tells us to, clean up with the CDK destroy. So I'll let that run in the background, and then we'll just keep going with the CDK Primer. See if there's like some more theory that we can kind of work through here. Yeah, so the core components that power the CDK applications are composed of apps, stacks, and constructs, sort of like what we went through. And now that we kind of got some hands-on experience with it, hopefully this starts to make more sense. Is that, we have this app, this stack, and the construct could include just a load balancer, but the construct could also include a container and a load balancer, right? So the AWS CDK uses compositions to define complex constructs. A composition establishes a parent-child build hierarchy. The parent composition is composed of child constructs or compositions. This nesting pattern can continue with deeply nested composition in which you define constructs inside of other constructs. Whoa. That's some like CDK inception. Ooh, that'd be a cool name for a new construct. We can call it CDK inception. Trademarked. So if you're out there and you can't steal my idea. To enable this pattern, you can define constructs inside of the scope of another construct. This scoping pattern results in a hierarchy of constructs known as a construct tree. In the AWS CDK, the root of the tree represents your entire AWS CDK app. Within the app, you typically define one or more stacks. Stacks are actual units of deployment and similar to AWS Cloudformation stacks. Stacks are made up of constructs and compositions. So this is what we wrote, same thing that we wrote in our CDK app. Let's go over and check on it. Still deploying. Man, like my entire IT career has been waiting on things to deploy, Hurry up and wait. Okay, so the composition of constructs means that you can define reusable components and share them like any other code. Teams within a company can define and distribute constructs as they would any other code library package. When one team updates a code library, developers on other teams can get the latest version and deploy any bug fixes and improvements. I really like that. I mean, I think that's I can't stress enough, like how many times I've had to rewrite the same exact like Cloudformation templates because we didn't make it more reusable or distributable. I don't know if that's a word. All right. So let's see here. Yeah, it's just kind of showing like how you can reuse constructs and import them into your other like applications and stacks. In this example, there are 3 teams. Okay, yeah, we get it. We get that. How are constructs used? Constructs are implemented in classes and extend the construct base class. You define a construct by instantiating the class. All constructs take 3 parameters when initialized: scope, ID, and props. So the scope, ID, and props. So the scope is the first argument. Scope is the construct in which the construct is created. In most cases, you define a construct in the scope of itself, which means you usually pass this for the first argument. Oh, pass it for this. That's the word this. Yeah, so it makes sure that it knows it's within this class. Yeah. So the second argument is ID. It's a local identifier of a construct that must be unique within the scope. AWS CDK uses identifier to calculate the Cloudformation logical ID for each resource defined within the scope. Yeah, so we were using that as a string, saying like my Fargate. The third argument is props is a set of initialization properties that are specific to each construct and define its initial configuration. For example, vpc.function construct accepts properties such as max AZs, cider. Okay, like those are the properties of like if we go back over, we can check on our it finished finally. Yeah, so like here we were defining the props of our VPC construct, right? So let's take a look here. So we have our outputs for the let's see. Okay, so it outputs like just the DNS name, I guess, and then the service URL, which is the exact same. So let's see if we can open this up in a. It opened up on the wrong one. Yeah, so it's a simple PHP app, and when I clicked on it, it opened up in a different tab here. But this is the image from Docker Hub that we were able to pull into our CDK application. So success. It's pretty cool. Pretty cool. I mean, that took like maybe 5 minutes or so. Then we were able to get that up and running. Not too bad. But yeah, I don't want to leave that running. And if I forget, destroy. If you're in CDK destroy, should bring it all down. I thought there was like a yes or no after you run that, but I could be wrong. Yeah, okay. Yes, we want to delete. All right, so back to this, building your own constructs. In addition to using existing constructs, you can author your own constructs. To declare a new construct, create a class that extends the construct base class and enter the scope, ID, props, and props arguments. You can build your own constructs when you want to. Organize your project, streamline your development process, package the construct into an NPM module. And if you're doing that, I recommend checking out the Progen or Progen, whatever it's called, Progen project. It's probably the best way to create an NPM module. Yeah, so this is like, you can imagine, you're creating this, web service here with an API gateway and Lambda and DynamoDB, and you publish it to NPM. And then now, like similar to how we, installed the ECS patterns module and the EC2 and what was the other one? ECS, I think it was. Now that you can like NPM install whatever the name of your module is, and you're able to easily reuse that same application stack or those constructs. So pretty cool. And this is just saying what I think I said. All right. So using predefined constructs for AWS resources, the AWS CDK includes AWS construct library to ensure that developers have access to all AWS resources while building their apps. This library includes constructs that represent all resources available on AWS. Okay, so for example, this code snippet shows how S3.bucket class represents an Amazon simple storage service bucket and its attributes. Constructs are self-contained. However, you can bundle the runtime code and infrastructure code in libraries that others can reuse. So I think the idea here is like, it's just saying like, hey, this is how you create a new S3 bucket. Right. Okay. Yeah. So So now it's kind of going into the different levels or layers of constructs in more detail. So the library contains 3 levels of constructs. Right. And so here, okay. Oh, so that would be a level 2 construct then, I guess. So level 1, I guess, would have anything that includes CFN in front of like the name of the resource. And that's literally like if you're writing a CloudFormation template, that is, the single one-to-one mapping of that. Whereas if you keep going like higher on these levels, starts to include more, best practices or more abstractions built into like the resources that you're trying to deploy. And then obviously up here, in a few lines, we were able to create a bunch of resources. So, level 3 or layer 3 is, a bunch of different services baked into a specific construct. Yeah, so I guess, I get a little too ahead of myself here, and you scroll down and it's like, here's what, instead of me trying to guess at it, here's what it says is the level 3 is are designed to help you complete common tasks. Okay, yeah. Let's see. Level 2, AWS resource constructs represent AWS resources offer convenient defaults. So it's like right above level 1, but it sensible defaults. And I think, level 1 you'll see is like these constructs directly represent all AWS resources available in Cloudformation. Cloudformation resource constructs are named after the service they represent. So you got like, this level 2, you can think it includes sensible defaults, right? But on level 1, you have to specify, every single detail that you want or that you need. AWS CDK Pattern Constructs. Level 3 includes AWS CDK Pattern Constructs developed by AWS engineers and provides opinionated best practice patterns by default. These higher level constructs stitch together multiple resources and are generally represent reference architectures or design patterns to help you complete common tasks in AWS. So I heard this somewhere before, is that you can think of these as like being able to stand on stand on the shoulders of giants. I think that's how it goes, is, like these are AWS engineers, some of the smartest people in the world, and they're developing and building these pattern constructs. So like, why would you try to do something that's completely opposite of what these guys are getting paid to build, with best practices in mind? It's a no-brainer. So we get to benefit from their work. And I don't mean to sound lazy or anything, but work smarter, not harder, right? All right. Get off my high horse here, but okay. So the AWS CDK pattern construct for VPC is at the center of AWS engineers adding new features. So I think they created that ECS patterns with the application load balanced Fargate service, and we get to benefit from that. Within a handful of lines of code, we were able to get up and running with this public facing service, in a matter of minutes. So pretty cool stuff. Okay, so AWS Resource Constructs, they provide the same resource functionality, but they handle many of the details required by AWS Cloudformation. Okay, so for example, the S3.bucket class represents an Amazon S3 bucket with additional properties. In this example, the name S3 bucket is specified as bucket name. All public read access to the folder is disabled through the public read access and block public access, and the removal policy has been set. Yeah, so that's pretty nice. You get that. That's really nice, actually, because you can't delete a bucket that has data in it. I don't think. I think you have to like empty it first and then do it. But I think what they're going for here is that this is a level 2 construct, right? Because obviously it doesn't have the CFN in front of it. So, right. And then here is the AWS Cloudformation Resource Constructs. So this is level 1. When you use AWS Cloudformation resources, you must explicitly configure the properties of the resource. This requires you to completely understand the details of the underlying resource model, the AWS Cloudformation resource constructs are named CFN and then the name of the resource. So right, yeah, and then here's like what is it, like the resource name or the endpoint, right? All right. And then the standard AWS CDK development workflow is similar to the common workflow that you use as a developer. And I guess, um, disclaimer, I am not a developer. So, like, maybe some feedback for the team that built this primer is that like they shouldn't sort of exclude like other people that aren't developers, if that makes sense, because I am certainly not a developer. I like have a network and system administrator background, but maybe if they reword this a little bit, it could be more inviting to sysadmin type people that um, wouldn't consider themselves developers. But I definitely think like the CDK is still a very approachable framework, and if you're already doing infrastructure as code, this is sort of just that next level of you know um, of becoming like a DevOps SRE type, or developer, whatever. It seems to be like blurring the lines of those in a better way, in my opinion. But anyways, again, off my heart, I've been on my high horse today, so apologize for anybody watching. So all right, and so the AWS CDK includes a few extra steps to synthesize your stack as to an AWS CloudFormation template and then deploy it. Okay, so you create the app, add the code to the app to create the resources within the stack, synthesize one or more stacks in the app to create an AWS CloudFormation template, deploy one or more stacks in your account. The app constructs. So every CDK application is represented by an AWS CDK class app made up of one or more stacks. Apps can contain one or more constructs. All right. Okay. So the app construct represents the entire AWS CDK app. This construct is normally the root of the construct tree, and we can sort of go back and reference our project here. I'll close this and this, and if you look at the tree here, right, like inside the lib directory was where we were describing our code. And then if you look in, bin, is it bin? Yeah, bin. There you go. Inside of the bin directory, here's where we're like creating the app, right? So it's like instantiating this CDK primer stack and building the app through this bin directory. So let's see here. Yeah, so if we had, so we're building the app and we're calling these different stacks, right? And if we had multiple stacks, obviously we would create like a new stack, I don't know, like VPC primer stack or something like that. And in that stack, we would only have like a VPC and subnets and whatnot, right? Nested stacks. Now, this is something new to me. AWS CDK gains its development power from Cloudformation. However, it is also bound by AWS Cloudformation resource limit of 200 resources. A way a way around the resource limit is to create a nested stack. Nested stacks are a little scary to me. I don't know. Like, you start creating, like, things could get out of hand quickly with nested stacks, right? Because you start creating all these dependencies within stacks, and then you sort of like update one area of your application, and then all of a sudden it breaks all the dependencies that are nested within it, right? Like, it just seems a little scary. Like, I've had better experiences with abstracting and kind of explicitly identifying what dependencies are required, and that's worked out a lot better for me. But let's hear them out. Each nested stack can contain up to 200 resources, while only counted as one resource in the parent stack. During app synthesis, each nested stack is synthesized into its own AWS CloudFormation template. Nested stacks are not treated as independent deployments and cannot be individually deployed or listed. However, resources between parent stacks and nested stacks are automatically translated to stack parameters and outputs in generated AWS CloudFormation templates. Yeah. Like, yeah, okay. I mean, so the idea here is that, this construct, right, which could include the application load balance Fargate service, that could include 10 resources or so, right? But this nested stack, which could also include 10 resources, it only counts as one. So you'd only have 11 resources within this stack, right? And it's a way to alleviate the resource limit with CloudFormation. However, like, what's stopping you from just creating a different stack next to this stack and abstracting, different layers of your application that way, rather than nesting them? So I don't know. I guess it all depends. Okay, so let's see here. Let's try and make it through module 3. AWS CDK concepts. To use a CDK, you must understand key concepts that make up the AWS CDK app. This module will focus on identifiers, environments, contexts, and assets. The AWS CDK uses various types of identifiers. To use the AWS CDK effectively and avoid errors, you need to understand the types of identifiers. Identifiers must be unique within the scope of which they are created. Familiarize yourself with the types of identifiers used. So construct IDs, paths, unique IDs, logical IDs. Okay, so a construct ID is the most common identifier. It is passed as the second argument when instantiating a construct. Okay, so that's like when you say my VPC, or right here, like my VPC or my cluster or my Fargate service. Is that? Yeah, that's what he's saying down here. However, the constructs are defined in different scopes. Wait, what? Oh, okay. So if we had multiple stacks, we could use the same construct ID. Okay, without conflict. Yeah. Okay, so paths, the constructs in an AWS CDK application form a hierarchy rooted in the app class. This hierarchy is called a path. The path refers to the collection of IDs from a given construct in its parent construct, its grandparent, and so on. To the root of the construct tree, AWS CDK displays paths in your templates as a string. Oh. With the IDs from the levels separated by slashes. The paths start at the node below the root app instance. Constructs must have unique IDs at their own level. This requirement creates a pattern where a path for two different constructs is unique. This uniqueness ensures that the hash generated to form the logical ID is also unique. Interesting. Okay. This example shows the AWS Cloudformation template, the CDK Primer stack template.json synthesized from the demonstration earlier in the course. AWS CDK path attribute is the metadata field, or in the metadata field, shows the path for the associated resource. My VPC is the first resource listed. Very cool. Okay. Kind of gives you like a better idea of like how it's organized, you know. Unique IDs requires all identifiers in the CloudFormation template are unique. To meet this requirement, AWS CDK generates a unique identifier for each construct in an application. AWS CDK uses the construct path to generate an 8-character hash. Okay. Yeah, okay, so I thought that was what a logical ID is, but let's see what a logical ID says here. So, logical ID, using the previous example in the VPC, created CDK primer stack, results in the name being that 8-character hash, right? Okay, so they're the same then, or? So unique IDs and logical IDs appear to be the same thing. Okay. Anyways, environments. This is a good one. Okay. Environments represent AWS accounts and regions which the stack is deployed. Okay, cool. So AWS CDK selects the default region and account in your current CLI profile. However, you can manually override the environment by specifying a different set of values than the default. So down here, you see like they're identifying an environment with an account ID and a region, which can be both different. And then when you create the stack, right, you're just passing in those environment variables basically. Okay, and you can use that with the CDK CLI as well. So if you export these environment variables for the default account and region, that could also be different than your CLI. So something to consider. I think my camera's frozen. Yeah, so then it just goes into more detail about your CLI as well. Um, yeah, not super interesting, right? Because you know it is what it is. All right, so context values are key value pairs that can be associated with a stack or construct. So AWS CDK uses context to cache information from your AWS account, such as availability zones in your account or the Amazon machine image. You can create your own context values that your apps or constructs can use. Oh, that's cool. I've never actually done that before. Context values that you create are scoped to the construct that created them, meaning they are visible to child constructs but not to siblings. Context values set by the AWS CDK toolkit are set on the app construct, and so they are visible to every construct in the app. Oh, okay. So context method, you might need to retrieve contextual information that is useful in your CDK app. CDK supports several context methods that is used to retrieve context information. So, if you wanted to look up your Route 53 hosted zone, you could use this like from lookup method, right? Or stacked out availability zones to see or to retrieve that context information. Um, let's see, VPC from lookup. It'll look up an existing VPC for you. Um, Looks up an AMI. That's nice, right? If a given value or if a given context isn't available, AWS CDK app notifies the CLI that the context information is missing. The CLI then performs the following actions: queries the current AWS information. Okay, cool. Assets. Assets are local files, directories, or Docker images. And so again, we kind of touched on this before when we were building out the our demo CDK application, was that we had those other methods rather than using like from a Docker registry. We could have used from asset, which would have we could sort of like look through our local file path to grab that Docker image. So an example of is a directory that contains a handler code for a Lambda function. Assets can be assets can represent any artifact that the app needs to operate. When synthesized, your application code or your application includes metadata information with instructions from the AWS CDK CLI on where to find the asset on the local disk. Yeah, so it's very useful for building Lambda, uh, functions locally as well, or in deploying those, right? And then let's see. So the AWS S3 assets are local files and directories associated with your app that are packaged and uploaded to AWS S3. Yeah, so that's awesome. I mean, you can upload files to S3 if you wanted. You can upload Lambda code directly as well. Really, really powerful stuff. And I think like on the back end there, it actually includes like custom resources, I believe, like using the using the Lambda function to do all that, which is nice. It's kind of like a utility on the back end, that just kind of does it for you. I can't imagine. I just like, it blows my mind when I think about all the Cloudformation that someone would have to write to, and someone probably already has written, right? And just to make this, and now it's just as easy as a few lines of code. It's just still just blows my mind. So and then, yeah, like I mentioned before too, the Docker image assets, bundling a local Docker image and uploading that into ECR is extremely easy. Here's a code snippet with how to do that with CDK. And, it's just a handful of lines. In this example, the Docker file is located in the local directory, and the CDK will actually build the Docker image and push it up to ECR. It's crazy. Yeah. All right. So I think that is where we will stop today. We are about 52% of the way through, and we'll finish off the remaining part of this primer in the next stream. Just looking ahead a little bit, kind of goes through the AWS CDK toolkit and the CLI, and then more about the development process, troubleshooting, and then we'll wrap up. So we'll finish that off in the next one. And yeah, thanks for watching, and I'll see you next time.